this light and fast. So our topic today is unlocking enterprise AI at scale. You already heard a lot about what generative AI can do for you, how exactly the innovations is actually happening. Let me add a little bit of color from the perspective of Cohere on how all this works. So for the folks who don't know what Cohere does, let me add a couple lines of color to it. Cohere is the leading enterprise internet provider in the world. If you look for the keynote this morning with Lisa, one thing that she spoke of really resonated with me. She had a screen with customer service on one side. You had a customer service agent, and you have regular interaction with an Amazon representative or something like it. And in the same breath, she also mentioned life-saving technologies. We have customers on both these sides of the aisle. We have customers that have millions of interactions with their end users on things like customer service. Quite often we have the end user speaking one language, you have the customer service agent speaking a completely different language, potentially on the other side of the world. You have the documents, the policies, the orders, transactions that the interaction needs to refer to, being in a completely third language. Our models are built to make sure that all of this works really well cross-lingually from a generative AI perspective. But on the other side, with clear contrast to this very important but mundane interaction, you have things like healthcare. And so our technology is also used to do summarization of patient healthcare records. So you have physicians and doctors, all the way from your internists or your general practitioners to specialists like in oncology, reading through, who previously had to read through pages and pages of patient history to really understand what was going on, even when they see the patient only once in 6 months or a year. They can now very quickly go through all of that in literally seconds with a very accurate summary. They can search within those notes if they want to go deeper and understand a particular piece more. As you can imagine, this is really critical from a life-saving or from a general humanity perspective. So we classify both of those under the use cases for enterprises because we usually see this from the lens of really large companies. And so today, I'll talk to you a little bit about what we do, what sort of models we have, what do we have in market, how we partner with A&E to take this even further, and then hopefully leave you a bit with some thoughts on what enterprises really do uniquely and why we cater to their needs in an exclusive fashion. So we have two types of models. You're very familiar with the first one, of course, generative models. We have a series called Command R. We have two models in that series. One is called Command R, the other is Command R plus. R is the small one, about 35 billion parameters. R plus is the larger one, just over 100 million parameters. And they do all the tasks that you're very familiar with, like summarization, very accurate summarization, being able to generate text based on the exact instructions that you provide, and so on. I'll point out that because our customers are global, it is really critical to be multilingual. So the customer service agent use case that I spoke of, if you keep extending that to global enterprises that need to work with several departments, several domains, several use cases across all of the major business languages in the world, you really need to have your model performing in a top-notch fashion across all of them. So we support all of the top 10 business languages. We support more than that. For the top 10, like English, of course, all of the major European languages, Chinese, Japanese, Korean on top of that, and even Arabic, which presents very unique challenges. But to pair with that, we also have really strong retrieval models. Two flavors in those. One is embeddings, and so we have an embed-free model, and also E-rank, which is a very innovative new type of model. I'll talk about that in a second. Embeddings are just numeric representations of your data. So for enterprises, one part is just being able to use the generative capabilities of models like R and R+. The second part is using those capabilities in conjunction with their own data. And this is not your run-of-the-mill consumer use case. You have a chatbot, you get a series of questions, you get some answers. You might throw in a PDF or 10 PDFs, maybe even 50 PDFs every once in a while. This is enterprise, so we're dealing with at a minimum, tens of millions of documents or artifacts, and for our largest customers, as much as 100 billion documents. And so when you're talking of that scale, being efficient with numeric representation matters quite a lot. And once again, because these are global businesses, it matters that we support the data in several different languages. So we have various flavors available in embed, from full precision all the way down to binary embeddings, which give you almost the same quality across all of them, so that you can do semantic search really, really well. But the difference in cost going from full precision to binary is significant. It's literally several orders of magnitude. But if you have several data sources, our top customers easily have hundreds of data sources, quite often with very specialized data types and very specialized search systems already built on top of them. In those cases, they're not going to start embedding everything from scratch. And so if you already have a good search system that exists, you can just use a VLAN on top. VLAN helps you just get all of the results coming in from all of these systems. Let's say you fire off a query, you have 10 different data sources, and you have the top 5 using existing search from each of these data sources. We now have 3 documents. Which of those are the most relevant to send to your language model for doing, say, material document generation? VLAN helps you do exactly that. One single line of code, and you can get the most relevant documents across the ones that you pull from all of these different sources. And so a pretty unique model, works extremely well, and so once again, available in 100+ languages. Let's see what this actually looks like in action. So since customer support is our flavor of the day, I'm showing an example with single-step tool use. The UI is one that we have actually open sourced. You can see the settings over there using a command R+ model with a small preamble to tell the agent how it's supposed to be interacting. You see some tools over here on the right, and we're just going to use one tool in this initial example that allows you to search pending orders. What's behind is actually just running a search across a specialized order system. So let's ask the question, which customers have pending orders requiring additional verification? Very quick return. We specialize in very low latency, and so you're getting exactly what you asked for. The answers are here. Can we do more with this? You'll see the reference. I'll talk about inline citations a little bit later as well. Can we extend this and actually have multiple steps so that you can do a lot more? Let's go to the settings again. You'll see that there's additional tools available. This is a demo, so these are not real-world tools per se, but our customers have exactly this use case in many forms with actual tools behind them. And so let's see if we can do more, as in create and send email to remind customers with pending orders for verification. You'll see that it's searching the pending orders, it referenced a specific data source, and now it doesn't just give you the names, it's also giving you all of the steps. These were retrieved from documents that will be used. And so no matter how many documents, we actually really will across several different documents, no matter if the answer is at the beginning and the end. Most models typically do much better if the answer is somewhere at the beginning or at the end. Our models search very well in the middle as well. It's typically one of the lost in the middle problems. And then with that data, you'll be able to just send an email as you saw as well. Simplistic example right now with only a few steps, but our customers have significantly more complex workflows and they're able to hence achieve a lot with this agentic workflow that is growing more and more in terms of adoption. As we heard already, in case it wasn't clear, we really focus on the enterprise. So what are the actual attributes that we are targeting and why are they important? Another thing that Lisa said this morning stuck with me, which was, she used the word end-to-end. This is really critical. I don't think the model and only the model is the most important thing. I think for a long time, the industry has given a lot of importance to just the models. There are a number of models now that are very good. You'll see some comparisons, I'll throw some benchmarks as well, real-world benchmarks too. We have a number of models that are very good. We have optimized them so that we have really strong operational performance as well. But just the generative model itself is not enough. You have to have an end-to-end system. So with embed and rewrite, you get that. We already spoke of massive bundle equality. The third part, I'm going to spend a bit more on this from here on. They're really built to scale. The example I gave about documents extends to the number of interactions as well. As a consumer, it doesn't really matter if you pay $20 or $22 for a monthly subscription. Sure, it's a small difference. For a consumer, it doesn't really matter as much. You have a few interactions a day, and the scale really isn't that much from a user perspective. But when you have users in the thousands at the very least, and the interactions go significantly higher, several orders of magnitude higher, you really need to make sure that your cost per interaction is absolutely the lowest. And so we build performance models that have much lower compute footprint. We'll talk about how AMD as a partner has been really helpful in this regard. And hence, coming to a really low total cost of ownership. Along with this comes fully customizability. One of the problems that we see with proprietary models, as well as open models, is that you don't really have access to everything in the model building phase. Since we build our models from scratch, we obviously have access to not just the end state of the model, but to all of the stages up to that measure. So we have really good fine-tuning capability as you would expect. So we have self-serve fine-tuning capabilities, for example, but we also have full supervised fine-tuning processing running on top when customers need that extra ounce of performance for their particular use case. So if you want to specialize, really get much better performance for potentially more out-of-band use cases, or something that is highly specific to your domain, your industry, you can get a lot better performance by specializing or customizing on top of performance. And this goes all the way to continuous pre-training, which requires hundreds to thousands of GPUs, and can be run primarily on our side because most customers don't have that infrastructure available to really give even better performance. Again, since we built our models from scratch ourselves, we can be sure of the data provenance. So as a customer, you have a guarantee from us that we will stand behind you in terms of IP identification. So any claims on the data that has gone into building the model itself, you can be convinced as an enterprise, this is especially important because you want to protect yourselves in front of your users. We stand behind you in terms of the data that's going into building these models. We do a lot of data procurement, privately for getting really specialized data. We also work with our own in-house annotators to really get better at how the data, especially for highly specific use cases or newer domains, how the model actually gets better at it. And you, of course, have full control in terms of where the data is. If you're using the data for fine-tuning, or even in terms of usage at runtime via RAG, the data stays completely inside you. For the last point, in terms of deployment flexibility, let's actually see how AMD is making a difference. And we'll talk a little bit about our partnership and what we've been doing with MIT and RX specifically, and we'll then extend into deployment flexibility. So first off, really happy to say that MNR and R+, we've been working with AMD right from the beginning, right since the GPU was available, to optimize our models for MIT and RX. They're available running at top performance. They'll be rolling out very soon to your favorite cloud provider or whatever platform you prefer to use our model on. And so by the end of the month, they should be available everywhere. A lot went into making these models operate really efficiently. And so I'm very grateful to the AMD team that worked very closely with us on this. Just as a headline, it definitely provides very efficient inference. Initially, when we started off, we were able to get it running very soon. It took on the order of days, not really a long time. So porting was really easy. Our default was TensorRT, because we've been using H100s for analysis so far for inference, and so we used DRT LLM. We switched to VLM for MIT and RX. And porting, just to get going on MIT and RX, was actually quite easy. Optimization obviously was not the same. It definitely took a lot more concerted effort, but the end result was worth it. So we have not just the models running extremely efficiently, we're able to take advantage of specific features provided by AMD as well. The first is the large memory capacity definitely makes a big difference. Our models on the generative side are 128K in context, and we were able to give full support for that with much smaller footprint than we've been able to do so far. So in terms of tensor parallelism, MIT and RX allows us to get the same results, but with much smaller TP. and that translates into much lower costs, obviously, for the user. We're able to take advantage of FP8, and we'll go to the quantization results in a second, but the fact that we were able to do so well with FP8 as opposed to full precision means, again, that we can do a lot more with a lot less. So let's talk about model quantization and quality a little bit. We started off with BF16 and then went to FP8. Auto FP8, getting it going was actually pretty simple, but and the quality loss, as you can see, was very minimal. But then as we tried to get even more out of it, AMD's clock really made a big difference. And so we were able to get even better performance on FP8 with clock. And this has been quite exciting, I think. With the amount of investment we put into this versus what we're able to get out, we're really happy. And so really looking forward to doing more with 325X, 355X, and with FP4 and FP6 that we're going to see with those as well. This is the Command R Plus and the latest flavor of which will be staged in August. It's the 0824. As a final point on the cost efficiency, you can just see the inference throughput with different tensor parallels. And so this is again based on R refresh as in the 0824 model for a particular profile, the one that we see pretty common, 1,000 tokens and 100 tokens on the output side. And so you can see that the throughput per instance actually increases significantly, even though you actually need to do less work per GPU. So in aggregate, you actually get significantly better performance. Where can you actually use this? This is where repurposability really comes into play. We are amongst the very few proprietary model providers that have a large number of compute clusters. The first, as you would expect, is our SaaS API. So we have a Cohere managed platform. The GPUs that you use on this will be transparent to you as users. You're just able to use the API, send requests, get responses. But we also run on all of the managed services on all of your favorite cloud providers. So things like Bedrock or Azure Model as a Service, which let you do things from a token perspective, but also SageMaker, which lets you just do things from a per instance perspective. You usually see that as customers scale, they prefer to have more control over their workloads and hence over their cost. And so things like SageMaker become more attractive because you have the capability to keep those GPUs running at full load. But we don't stop there. We also go all the way to virtual private cloud. And so the largest customers who often have very large footprints in hyperscalers will often have special VMs, will have really strong upgrades for GPUs already with these cloud providers. And so rather than use managed services for convenience, will often want to run our models in the most performant manner. And so we give our entire stack in the same exact manner that it operates on our SaaS product all the way to VPC. And so you get the same feature set, but in the environment that you prefer. And to take it to the extreme, we do the same on completely private deployment, which can be in a colo, in your on-prem environment, all the way to completely air-gapped environments as well, which are really important in certain regulated spaces. And so the last one especially makes us work really hard in terms of optimization. So we spoke of efficiency a little bit earlier. If you look at fine-tuning as an example, normally we talk of efficiency only in terms of inference, but we also have to think of the stack in terms of things like customization. So when you have a much smaller number of GPUs available, because of constraints on the GF that you're deploying in, potentially because of the location, as in literally what is the size of the facility, what is the power consumption that you can max out on, what is the cooling capability, and so on, which can be very different from running it hyperscaler versus running in your own facility. You really need to think of how much more you can do with a minimal number of GPUs. And so with innovations like stack fine-tune that we came out with almost a year ago, you can actually run several fine-tuned models on a single GPU. And so the more efficient we get with GPUs, the more these features matter because you can continue to save on costs without actually lifting a finger. And all of this with all of your data sitting in every single data source. So this is just a sampling of the data sources that are supported in order to do things like retrieval augmented generation. And there's several more. We do a lot more in terms of in-depth connector optimization for several of these as well. We can access data in So what does this mean in terms of actual performance? We spoke of multilingual a bit. I just thought I would throw this up just to show the out-of-the-box multilingual performance. We'll again talk about customization a little bit further, but Command R is significantly smaller, for example, than Llama 70p, and yet has incredible or better performance. The same with R+, significantly smaller than GPT-4, but still very much competitive in terms of multilingual performance. But it's not just in the end model performance or from a quality perspective either. In terms of cost, we try to optimize at every single layer of the stack. And so from a tokenization angle, for example, if you take a look, you see a difference across the board with us versus the competition. But you see, especially that difference in certain cases. So Arabic, for example, OpenAI uses 1.7x the number of tokens that Cohere uses for the same amount of text. This translates massively into difference in cost. And again, think of this in terms of enterprise scale, matters a lot more than on the consumer side. Trust is very important with enterprises. Consumers are a lot more forgiving. If you see something that doesn't quite make sense, you'll dig a little deeper or you'll just give it up. Enterprises won't, and customers of enterprises definitely won't. They expect quality, they're paying for it, they absolutely need trusted, verified answers. So out of the box, we provide very good, very low rates of hallucination, as you can see again. But we go one step beyond. We have features like inline citation. So if you remember in the demo earlier, there was a pane at the right that actually showed you where the data came from. That is the default with our RAG interactions. And so anytime you actually retrieve a snippet, you have a particular data point that you're picking up from a document. You get an inline citation to that. You can click on it so you can verify that the data that giving you in the answer is actually accurate. We spoke of the generative models so far. Let me go a little bit deeper into embeddings as well. This is a comparison of performance for embeddings. Not every competitor actually provides embeddings, which in itself is interesting. But for several tasks on the consumer side, you don't really need embeddings. When you're chatting with your favorite chatbot, you don't really think of embeddings at all. But enterprises really, really care about embeddings, and so it's another thing that we focus on. You'll notice that there's two distinct benchmarks there. One is just BIR for English, and the other is a specifically noisy data set. The second one matters a lot more, and we are clearly competitive on the first one too. But the second one matters a lot more in the real world, because real world data is imperfect. Every single enterprise customer tells us that the data that they have is broken in so many different ways. They often don't even know how broken it is until they actually try to make sense with it with our model. And so in the past, the amount of insights, the amount of access you can actually get to the data was significantly lower. But with Gen AI, you'll now be able to delve a lot deeper into the data. And so any inconsistencies, any problems become apparent much quicker. We perform a lot better on noisy data specifically, and at significantly lower vector-DB storage costs. So when I was mentioning the full precision versus all the way down to binary embeddings, you can see the difference in cost over here. And all of our models are very much to the left over here, so significantly lower in cost. But binary within that, even another order of magnitude lower. Again, matters a lot at scale. And last comes rerank. So we already have very good visual performance using embed, but can you actually improve it even further with rerank? So on the left you see EM25, very standard early generation algorithm for search. If you just add rerank on top, literally one single line of code, you get a significant boost in accuracy for a search performance. And then if you use our embeddings, if you apply rerank on top, you'll get still better performance. That's the one that you see on the right-hand side. And again, in pretty much every language that will be. The net result across all of these is that we get very, very good retrieval augmented generation at a very optimal cost. This is on 10K RAG forms, very useful with our customers. You can certainly scale this up even further. Very high accuracy, very low cost. I'll just take a couple of examples for these based on the customers that have already made these public. Oracle, certainly a very well-known name. Big business challenge when they started out with GenAI. How do you offer GenAI solutions in OCI, Oracle Cloud Infrastructure, so that you can supercharge businesses? They have a lot of enterprise customers, thousands upon thousands. How do you offer them the right GenAI solutions while being flexible and maintaining the accuracy that their own applications have been known for? You have to have enterprise-level security, customizability, and then the right user control that users have already been used to. The first thing we did with them was help them optimize the models so that they can get all of these. So the security, customizability was already a given, but to actually get the use cases really, really accurate, especially with a model that is much, much smaller, we help them customize so that they could get the best performance out of them. And so after due diligence, after running a significant number of evaluations, we selected Cohere or OpenAI and Llama to be able to run several use cases. At that time, there were over 50 new business use cases already in production, with over 200 actual features as part of their largest enterprise application suite, Oracle Fusion and Oracle NetSuite, with several more in the making. And the domains are very varied. You have HR, finance, supply chain, marketing, finance, the ERP as well. And then use cases across the board, article generation, summarization, pretty around the world. But then also things like supplier recommendation, which can immediately result into savings for the customer. So on one hand, you have a boost in productivity. On the other side, you have more savings, potentially more